right around the time that or just before the name change, this here at Michigan Tech, the School of Technology kind of divided into two major parts. One part came into the College of Engineering, and you guys were part of that.
Yes.
And then another part joined the newly fledged College of Computing.
Yes.
So, for example, mechanical engineering technology, a 4-year degree, is now one of the departments in the College of Engineering here at Michigan Tech, one of our 9 departments. And you, as geospatial engineering, are part of the Department of Civil, Environmental, and Geospatial Engineering.
We are, fortunately, yes.
And yeah, no, it's a great department. It's an absolutely great department.
Oh, fantastic. And as a result, and we can say in great part, our enrollment has increased tremendously since we've been accepted and brought in as part of civil and environmental and now geospatial. There's these numbers that constantly bounce around in my head. When I started, or when I was asked to teach and help out with the one class back in 2017, we had 3 students. We had 3 students in the surveying engineering program. We now have 42.
Yep.
So, and 7 of those 42 are individuals that are civil engineering majors seeking a 2nd degree in geospatial engineering. So they're getting their dual degree.
Well, and there's a lot of value in it because by law, I mean, you have to be a licensed professional land surveyor, which is what you get. You can become, right, with the geospatial engineering degree in order to do, engineering where you're paid for your work and where you have to, certify, the edge of a property and that sort of thing.
Right, and primarily that is the case because of the fact that we are a regulated profession, as our civil engineers, as our environmental engineers. You sign and stamp something, the product of your work or your deliverable, we are licensed. And Michigan is one of the most rigorous states to become licensed in.
Well, and you have a stamp, right, that you certify your work with. No, that's pretty
ultimately cool. Yes. Whatever final product that is produced by any of us is signed and stamped. That's correct.
Oh, so a quick story right before we get officially started. I met an alum, and I won't state his name but he was part of for a senior project that was oh gosh, I don't know if I'm not going to get the story right, but for a senior project, he and several of his colleagues surveyed the part of the golf course.
Yes, they did.
And he still has the drawings. He still has the original. I mentioned you should these could become part of the university archives, because this is really important history, especially that the surveying was done by students,
Yes.
So
and yes, they actually accomplished hydrographic survey of a few of the water hazards on Portage golf course. So they had some pretty interesting equipment to accomplish that, but it wasn't.
Well, and this surveying was done before the purchase, I believe. It was done to sort of theoretically figure out.
Oh, you mean way back? Okay.
Way back. No, yeah, this is a person who graduated probably 50 or so years ago. I don't remember exactly.
I got you. Okay.
Yeah, no, it was before the board authorized the purchase of, I think, the back part of the golf course, but I got to get my facts straight before I say anything else. All right, so we are coming up on the hour. I will find my slides. Oh, Echo, stop it. Echo's saying hello here. You got to say hello to Echo. Echo, say hello. Come here. Don't be shy now. Come on, show me your head. There you go. So she's knocking my elbow up in the air because even though she has kibble in her bowl, she would like me to add some cheese or something to make it more palatable. Abby, sure. I know. You go too. Everybody go. All right, give me a second. I am going to launch my slides and share screen. All right, can you see my slides?
We sure can.
Here we go. All right, good evening, everybody. Welcome to Husky Bites Season 7. We are in the year 2023. My name is Janet Callahan. My role here at Michigan Tech is that I am the Dean of the College of Engineering. and this is Husky Bites, a free Zoom webinar that then is posted later on YouTube and in all sorts of places. So if you're seeing this later, welcome to Husky Bites. We also live stream this through Facebook Live, and we also post them. So if you ever miss one, you can just go to mtu.edu/huskybites and catch up on some old webinars. So this is what Echo did this weekend. We did this run twice because I was looking for my lost mitten. So we this is where we park at Turning Rapids, which is on the way to McLean State Park on the right, and then you go uphill, up, and then up the thoroughfare for a really long way. And at the top, you kind of get to this nice big open space with I think that's a deer blind, although you'd have to be a blind deer to not realize that it's a deer blind, but it's a vantage point. And we ran into Gabriel, Dan, and Alicia, who are studying, I got to get this right, geology, forestry, and physics. Alicia being the one studying physics. And so Echo decided they were out there for a field trip, and she stopped and said hello and had a good time with them. So tonight we'll be talking about geospatial imagery, and I will introduce the speakers in just a moment. I do want to give a shout out to the fact that it is Winter Carnival week, and that we are embarking upon a really cool thing called Give Back, which is a 48-hour days of giving that begins on Wednesday, February 8th at 4 p.m. And so the website URL is giveback.mtu.edu, and I encourage and ask everyone out there to give to Michigan Tech during this 48-hour period. I am an ambassador, and I'm in competition with the other ambassadors to see how many people we can get to give. And so we have some kind of incentives. We have an incentive of Michigan Tech Engineering College of Engineering t-shirts. We have an incentive of some printed metal Huskies that I'll show you in a minute. You can win a sweet sweatshirt from the Society of Women Engineers. And also we have just a wonderful matching gift from Ralph Larson, class of 81, who's going to match gifts to Prep for Tech up to $3,000. And then the advisory board, he also incentivized the advisory board to give, and they're matching to 10,000. I know that's a lot of money, but there's a lot of people out there. So I'm going to show over the next 3 slides 3 areas in which you can give. First one is for STEM outreach Prep for Tech, both of which are eligible for the 3D printed metal Husky. The second one is for sweet scholarships, where you get the sweet shirt. And then the third one is a College of Engineering General Fund, which helps me be able to do things like send postcards about Husky Bites and things like that. All right, so now what you are seeing, what do you call those little things on the left? What are those called?
QR code.
QR code. I knew somebody would know the word. All right, you are seeing a QR code. And if you're like me, you're like, I don't know how to use those things. So I'm just going to tell you, if you turn on the camera of your cell phone and you take sort of aim the picture at that QR code, right? And then a URL will come up. If you then touch the URL with your finger on your phone, the site to give will come up. Now, don't give now, wait for days of giving. Wait till Wednesday at 4. But I just wanted to kind of let you know. And if you prefer a URL, there's the URL. And I will be following up with all of the Husky Bite Pack with this information in an email. And so what is Prep for Tech? It's a 1-week-long math boot camp that it's voluntary. We don't make students do it. And about 10% of our entering class elects to do this. And we've done it the past 2 Augusts. It's the week right before classes start. The second area of giving is in support of scholarships for the Society of Women Engineers. The third area I suggest you give is just in general support of the College of Engineering. And if you want to give to your home department, if you want to give to athletics, if you want to give to Mont Ripley, just go to this URL, giveback.mtu.edu, because there's a whole bunch of other ways, places to direct your gift. And I encourage you to have fun with it. Last time there was something like this, I ended up giving it like to about 20 different spots at Michigan Tech, and I had a lot of fun with it. So I hope you enjoy. So go to giveback.mtu.edu February 8th and give back. And this is what the 3D printed Husky looks like. They are a really fancy alloy, and I don't have it handy to tell you what it is. And there are ones that say College of Engineering, and there are ones that just say Michigan Tech. So whatever you want, you are entered into a prize there. Next week, Jen Jung, whose last name is now Lucas, class of 09, who was on the volleyball team herself, is going to be the host, and we're going to be featuring the volleyball team. And so I really, the name of this talk is called "Digging It," which is a phrase if you play volleyball. It'll be awesome fun. So I encourage you to join us next week. And with that, I'm going to close my slides, and you guys should get your slides started while I introduce Joe, and then I'm going to leave it to you, Joe, to introduce all your other team. So it is my pleasure and honor to introduce Professor of Practice Joe Foster, who is a member of the Department of Civil, Environmental, and Geospatial Engineering. Joe studied forestry at Michigan Tech, where he earned his bachelor's degree, and then he earned another degree in surveying at the time, based upon the fact that he loved a course that he took, where he learned it was an entire profession, where you could work outside, where you could use sophisticated equipment, and actually apply math, in a way that makes sense. And sometimes when we're taking math, it's hard to know how we're going to be applying it, but Joe has learned to apply it in 3D ways. Joe was born and raised in Muskegon. He has strong family ties to the Upper Peninsula. His beloved sidekick is Deirdre, who is his 5-year-old hound mix, and she's a lovely dog. And with that, Joe, I'm going to turn it over to you.
Well, thank you, Dr. Callahan. Good afternoon or early good evening to everyone, and thank you so much for joining us. I am Joe Foster. I'm one of the teaching staff here at Michigan Tech in the College of Engineering, specifically in the Department of Civil, Environmental, and now Geospatial Engineering, of which we will be talking about tonight. And would like to feature a few of our students, Brayden, Brincks, Wes Hyslop, Case Vander, Heide, and Jacob Wysko, who are all leaders and members of our Douglas Houghton student chapter of the National Society of Professional Surveyors, who we'll talk about a little more at a later time here in our presentation. We're also affiliated with the Michigan Society of Professional Surveyors and are active in many events that are offered through it. But today we want to concentrate, or at least give you an introduction to that which we do as part of using some of the tools in our toolbox when it comes to surveying, geospatial engineering, in order to capture some of the images and more specifically the snow statues that are built on campus during Winter Carnival. So we'll go from there and head her off.
All right, thank you, Joe. So I am Jacob Wysko. I'm one of the students here in DHSE, just as Joe mentioned. Yes, and we're going to take a look at some of the techniques that we used to do these geospatial imageries of the Winter Carnival statues. So we'll just kind of dive right in. Talk a little bit of terminology, just that way we're all on the same page. So when we do these sorts of scanning projects, we commonly talk about point clouds and 3D scanning. So just a little bit of an overview on kind of how this whole technology works. So 3D scanning is the process of using some sort of remote sensing to capture a room, an environment, or some other scene that we're wanting to measure. And 3D scanners, they do this by emitting infrared light. And what it actually does is it takes the amount of time that the light travels to determine a distance. So we call that the time of flight. So the amount of time it takes for the light to leave the instrument, bounce off a surface, and then come back to the scanner, we can use that time to determine the distance. We can also combine that with some phase offset, and that gives us a really high accuracy number as far as a distance. So this is good for one direction, but what we really want is to have a bunch of lights going in lots of different directions. That way we can capture all the different objects around us. So what our scanners do is they spin, and so that light gets projected onto all surfaces around us. So then we can capture the entire space. This gives us what we would then call a dense point cloud. So we have a bunch of different points in all these different locations. All together, they help us form some sort of shape. And depending on the scanner, it can take either, you can go all the way up to 1 million points per second. So sometimes they only go down to 1,000 points per second. If you need more accuracy and less speed, less dense point cloud, you can kind of change the amount of points that are being taken per second. And then actually the backdrop on this slide here, we'll talk about it a little bit later in the presentation. But this was scanned with one of the scanners we have, and it's called the Matterport Pro 2. It's meant for mainly for real estate visualization. So real estate agents can show to their clients the space that it is that they're trying to sell. But it serves doubly as a great LiDAR scanner. So there's that. Now, the problem, just like a normal camera, is that if there's something in the way of the scanner, we're not going to be able to see behind it, right? Like, let's say someone jumps in front of the camera and they photobomb, you can't see what's behind it. Just like a scanner, right? It's just normal light. So we can't see behind it. So if we kind of take a look at these two different diagrams, or these are 2 point clouds that we're seeing on the screen. The left one has captured the front face of the building, the ground at that current elevation, and some of that nearby foliage. And then the scan on the right, we're seeing what we could call the west side of the building. So that's another face of the building that first scan, it couldn't see. So now we've got 2 different scans that are covering 2 different portions of this area. So what we can do now is combine these 2 scans together to create one larger scan. And so we call this registration. So this is typically done once all of the scans are completed, and we load all the scans to some software, and that will use a variety of techniques to determine how each scan is positioned in relation to one another. In this example, probably what was done was a technique called coincident geometry. So there are some distinct features in one scan that also appear in the other. We can say, oh, well, I recognize these 2 features. They should be in the exact same place. We can do that a few different times, and that helps us establish both a location, also a rotation. So the other way we can also do it is we can place targets in the scene before we begin scanning. So if we know an area has pretty uniform topology, like let's say we're out in the middle of the forest, each of the trees, they all kind of look the same. So it's going to be hard for the software to distinguish one tree from another to know where exactly these scans are in relationship to each other. So what we can do is place down some targets, and the targets that we use, they actually look like little spheres. They look like the little, what's it called? The viruses that...
Microphages?
Yeah, microphages. They've got like a big sphere on the top, and they got little legs that stick down, so it just sits on the ground. But that just gives us a very discrete object that we can see in the screen, on the scan, rather. So it shows up nice and big. And then we can take the points that actually land on that sphere and then calculate the center of that sphere. And then we can do that for each of the scans, line up those centers together, and then we have them registered. So now, kind of applying this to the Winter Carnival statues, here's some pictures of current statues that are being built this year. Top left is Phi Kappa Tau, I believe. And then we have 2 more on the right. Am I right on those names?
Mm-hmm.
Okay,
I believe so.
sweet. All right. So if we now think about the Winter Carnival statues, let's think back to last year now. Here's a trivia question for you. Who won the month-long snow sculpture contest last year? So our options are Phi Kappa Tau, Delta Upsilon, Theta Kappa Epsilon, and Sigma Tau.
Wow.
We got a smart audience out there. I'm just saying.
That's right. That's for sure.
It's gonna be really tough to trick them. So it looks like over 60% are voting for Phi Kappa Tau. And in second place is Theta Kappa Epsilon. I also remember it being a three letter for fraternity.
Yeah.
It's the one out over there in Hancock on the
It is.
heading out, yeah,
Yep.
which is what? Phi Kappa Tau?
Yes.
Yes.
Yeah.
Yes.
Okay, all right. The audience got it right.
All right. Woohoo. All right. Phi Kappa Tau it is. All right. So
Cool.
now if we think a little bit closer as far as the actual process that we did to do these scans. This is the actual scanner that we used in this case. So this is the Faro Focus 3D. It's a LiDAR scanner, which means it uses that technology that I talked about previously. LiDAR, it can mean a couple different things, but a common definition is light detection and ranging. So there's two parts of that. There's light detection. So if I emit a beam of light and it reflects back, okay, now I know that there's an object there. If I emit that beam of light and it never hits anything, okay, well, I know there's no object there. But if it does hit something, that's where the ranging comes in. So how far away is that object? So when we use the scanner, it takes millions and millions of points to capture all the objects around it. So we're able to determine if there's an object there and how far away that object is. And just like how I talked about, it's like a normal camera. If you want to capture more than just one little area, you're going to have to move the scanner around. So we set it up at multiple stations to make sure that every angle and feature of the sculpture was captured. Station just means a certain location that we set up the scanner and ran a certain scan. And then for this scan for Phi Kappa Tau, we set up in 11 different locations. Going from either side, in the back, in the front. We did a couple setups in the middle of the sculpture as well. And this is an example of one of them. Here's the scanner sitting in the middle of the sculpture. And that just helps us make sure that all of the faces of the buildings and the sculptures, people, all that geometry is collected. So overall, from the front, back, sides, everything, we captured 123 million points for this scan. So a big.
Did you do it? You did it right after judging happened?
Yes. Yep. So they were declared the winner, and we went out and scanned it. So
it's so impressive what these.
It really is.
It's just
Yeah.
incredible.
It
What
is.
artists.
The scanner also picked up some other things besides just the sculpture. So there were a lot of people there that day. So we kind of had to do a little bit of crowd management. So we had to set up in front of the sculpture to capture everything that you could see from the roadway. But there were also people on the sidewalk. So we had to make sure that we weren't in their way and they weren't in our way. But the scanner picks up everything. So it picked up all of the people that were around. It picked up nearby power lines, utilities. It picked up the house that's just next to the sculpture. It picked up the parking lot across the road and picked up all the cars. So we were actually able to determine how many cars were there that day. So, and it also picked up us. So we decided to not, we were kind of lazy. We were like, well, we'll just stand behind it. You know, we will get in the way. So every time there's a scan, you can see a group of 3 people. It was me, Wes, and Brayden. We're all standing behind the scanner. So you just see this group of 3 people moving around all the time because we show up in each scan. So there's like duplicates of us in the scene. So it's kind of funny. Typically, we try to avoid placing any object in the scene or standing within the scene. So that way later, when we process the data, it's not contaminated with unwanted objects like people, the equipment, the case, whatever. We can classify the point cloud later to remove those unwanted objects, but it's just easier if we didn't do that in the first place. So just kept the scene just what we want in there. So here's a picture, same picture of that scanner. Now let's flip over to the point cloud version. We'll do a little transition here. And now what you're seeing is the fully registered point cloud. So previously we just saw a picture that I just took with my phone camera. But now this is a screenshot from the software that we use to process the scans. And this is what it looks like once they've all been registered. And the grayscale color that you're seeing here, it's that surface, it's its reflectiveness to IR light. So if the surface reflected it more strongly than another surface, that's going to show up with a brighter color. And that kind of makes sense, right? Because if you look at any object within the visible part of light that we see, some objects are more sensitive to those. So like a red object, you know, is going to be more reflective to red light. So in this case, it's IR light. That's the kind of light, or that band of electromagnetic radiation that the sensor uses. We can use color data along with the scanner. So it can also take a panorama picture and then sort of superimpose that onto the point cloud. That way we capture color information based on the room or environment that we're in. We decided not to do that for the scan because it was all snow. So we were able to just say, well, all these points should be white. And then we can apply some shading and some nice post-processing effects to it later. So that kind of sped up the amount of time, because that takes about 3 minutes per scan to just do the picture. The scanning process itself depends on how high you've set the quality, but that can run from anywhere from typically 2 to 5 minutes. You can make it run up to as long as 2 hours to do a complete scan, but it's kind of overkill at that point, kind of placebo quality. So we just ran it for a couple minutes, and then we decided to not do any color information because everything was snow. So here's the point cloud, but what gets really interesting is when we can turn this into a mesh. So a mesh is connecting all those points together to form a closed polygon. And then once we do that, now we can start to apply some shading. You can see some shadows. And then the general geometry of the object that becomes more clear. So we can run that through some software, which will stitch the point cloud, I like to call it, stitching that together into a 3D model. And then we can apply shadows, and in this case, also some ambient occlusion. So what that does is it makes objects that are really close to each other, and it gives them a little bit of shade to it. So we can really see like the brick on that building there, really see each individual brick pop out, because otherwise this whole thing would just look completely white. But once we add shadows and some ambient occlusion, we can really see the geometry of the object. Finally, one more thing, looking at different techniques of scanning. So here's another example of a scan we did. And this is the Husky statue in the plaza right out front of the EERC. The left is a photogrammetric model, and this was obtained by flying a drone around the statue and taking photographs from a bunch of different angles. So then we can run those pictures through software, and it will try to reconstruct a 3D model based on what it sees in that object. And the process of photogrammetry is very different from LiDAR. So it actually uses parallax to determine the distances of objects within a photograph. LiDAR is directly emitting light and seeing how long it takes for it to come back. Photogrammetry is looking at pictures and seeing, well, here's the same object in 2 different pictures. If I know it's the same object and I know how much the camera has moved, I should be able to kind of expect what that object should look like. Like if you look at an object and then you move a little bit, in your field of view, it kind of gets distorted. So we utilize that fact to create a 3D model. And then on the right, we do have a LiDAR scan that we did this fall. And we found that we got better results for the Husky statue with the LiDAR. And this is probably because we flew the drone at a considerable distance from the statue. So the drone was probably at least, 25 feet from the statue at all times. So if you're looking at the 3D model from that distance, it looks pretty normal. But when we get close to it, some of that detail does kind of get lost. So there's a different application for each type of scanning. And it depends on what kind of application you're applying it to. The other thing to consider with photogrammetry is we might have also gotten a better solution by taking close range photos just with a regular DSLR or phone camera, point and shoot camera. Because we were at a distance away, some of those details get lost as the camera gets further back. But we might have been able to get a closer range photography and see some better quality that way.
If I can just jump in here real quick.
Jake, one of the things that that we'd like to make or at least bring to the forefront is that this is a piece of equipment that actually, like I started.
You guys, we're getting feedback. Turn off a speaker.
We're going to say that it's another tool in the toolbox, which essentially is exactly that. And we have 3 scanners that we have available to us, and we'll talk about the other ones here in a moment. But one of the things that comes out of this is that each of these points that create these 3D images or these scanned images have attributes. So they have an XYZ or a northern easting elevation in space. So we can accurately and precisely measure between and among all of these points that are collected. So it's more than just a cool looking picture or a 3D image. It's something that you can actually measure from. And that's one of the primary uses that we have for it. Yeah, as we move forward here now, this is all work that our students have been doing over and above their required classwork or coursework. And you will find interesting in some of the other slides that are going to follow here are part of the coursework and some of the other equipment that we had used. But it just shows you how interested these individuals are, how hardworking they are to be able to learn how to use all this equipment and apply it to real life situations and collection of data.
Yeah, we're good. Okay, so I'm sure most of you alumni are familiar with this, but this is the Red Ridge Dam, maybe 15, 20 miles south of campus, right off the shore of Lake Superior. And so this dam was constructed about 1901 by the Atlantic and Baltic mining companies. They had a stamp sand mill just downstream of the mine, and they are just downstream of the dam. And so they built it to ensure they had a steady supply of water. And so stamping is a process where you take the mined iron ore and you crush it. So that's pretty water intensive. And if you've ever been to breakers, all that black stamp sand there is the leftover fragments from the process of removing the copper. And so Atlantic and Baltic lasted till about 1922 is when they shut down. So this dam didn't last forever, but what makes it impressive is it's one of only 3 steel dams ever built, and it's the largest of the 3. It's still standing today. In 1941, it flooded on Easter Day, and so holes were cut. You can kind of see them in the bottom of this image, but 6 holes were cut in the bottom of the dam to prevent overtopping during floods. Because obviously there's the town of Red Ridge there, and
so
we don't want
what
the town getting wiped out. And
And
so
Can I just ask, so what you're saying is that the height of the water can never get above where those holes are? Yeah,
could you repeat that, please?
so we can see water flowing through right at that about approximately mid-level of the dam or slightly right. So that's the maximum the water level should get to under normal circumstances. So that's why doing that is going to prevent future flooding.
Correct. Before the holes were cut, torch cut there, the water was able to rise above the dam because originally the dam was meant to hold back the maximum capacity of water. But with the mining companies closing the stamping mill, the reservoir was not needed anymore. And so the holes were cut to protect the town of Red Ridge.
Got it. All right, you're muted, Brayden.
Okay, I'll keep going. Okay, so obviously being the only one of only 3 steel dams ever built and the largest, we wanted to, it's pretty significant. So it was listed in 1985 as on the Michigan Historic Civil Engineering Landmark, which you can see in that bottom left image. And then in 1992, it was listed on the National Register of Historic Places. So pretty cool structure up here in the Copper Country. And I think we can go to the next slide now. And so I'll let Joe take over this one. This talks about Siler and some of the cool equipment we used on this project.
Well, as you'll see in the next slide after this one, actually, this was part of the coursework in one of the geospatial engineering courses that is taught by Professor Hollingsworth. And unfortunately, he's not with us here today to describe it, but our industry partner in Siler Instrument has been kind enough and through their kind offering of equipment that we've been able to use over the years. What you see in front of you in this particular photo is the Trimble SX10. And as part of the work for the project that was in this coursework, not only was the SX10 used, which is a scanning total station, but the R12i GNSS receivers and the TSC7 controllers, as well as the software, the Trimble Access, were all used to actually put real numbers on all of the scan that was done on this project. So not only is it engineering grade, it's survey grade. So we have the equipment that is available to us thanks to Siler Instrument.
Awesome. I think I'm ready. We can move to the next slide. So here's an image of our point scan we collected for the class project. This class was SU 4142 terrestrial LiDAR scanning. So the emphasis for collecting the scan was back in a couple years ago. There was a Father's Day flood, and the Salmon Trout River, which flows into this reservoir behind the dam, received about approximately 7 inches of rain in 6 hours, which is just crazy. And they estimate water backed up, despite the holes cut down below, 2/3 of the way up the dam. And this water gushed through, and it actually knocked out one of the supports. And so the dam is not likely to collapse, but its condition is not getting any better. And so we wanted a 3D model to remember it. We used the Faro scanner, and we had 5 setups. And so the most difficult part of scanning this was the vegetation. Obviously, if there's a tree, the LiDAR cannot penetrate through the tree and get to the dam, which is the object of interest. And then additionally, any trees that are in the scans also get collected. So we have to bring that back to the labs on campus and try to remove all that vegetation. So this model was submitted to the National Register of Historic Places, and our work on it was submitted in XYHT magazine, which is one of the premier geospatial engineering magazines out there. So another cool part of this project was we actually geo-referenced it, and that's where you give XYZ coordinates in real world to the model. So we used Trimble R12i receivers, and to do this, we would set up on 2 points unknown, and we use these receivers to collect about 20 minutes of GPS data in a process known as rapid static. We would then compare that GPS data to GPSs that the National Geodetic Survey has around the local area. So they're all continually operating reference stations. There's one in Copper Harbor, Ontonagon, Houghton has one, and just this past summer, one was put on Isle Royale. And so by comparing it to these continually operating reference stations, we can remove the errors. We can get down to about 3 millimeters horizontal and 5 millimeters vertical accuracy. So, I mean, that's within your thumbnail. And that's awesome for survey grade work. And so you can see in this image, that is not a GPS receiver. That is the SX10, which is featured behind Wes, behind his left shoulder. And so we were able to set up on these 2 known points now that we had, yeah, there Joe's showing it off. We were able to set up on these points and backsite or turn with a known location. We were able to shoot points on the dam For instance, a corner of one of the ties, or maybe a bolt down below, and give it an XYZ coordinate. We then took these XYZ coordinates back to the lab, put them with our model, and we were able to rotate it to get it to a real world coordinate system, which was also submitted to the National Register of Historic Places. So that's pretty cool. Then I think we can move to the next slide. So these GPSs that the National Geodetic Survey operates, there's actually one on the Michigan Tech campus. So we'll see how well you guys know campus.
Where can it be?
All right, so the question is, there is a CORS on Michigan Tech campus. Where is it? A, Great Lakes Research Center. B, Lot 21 by the U.S. Forest Service. C, rooftop of the meme. Or D, the A.E. Seaman Mineral Museum. And the audience is really not so sure about this one, but a lot of people are guessing the rooftop of the meme, since the meme has so many other things on its rooftop. It might and it is a nice high spot. So gosh, next there's no strong majority on this one. I think I'll be interested to hear the answer.
So I think it's actually about an A.E. Seaman Mineral Museum. So the meme is a good guess, but you do not want the GPS to move if you're going to get millimeter accuracy. And it's possible the meme could sway just a little bit. And so up by the Seaman Museum, it's way up high. The GPS has good signal, not down in the valley.
I think that's the first time we've been stumped, possibly the whole Michigan Tech audience. Good job.
You start?
All right, so now we're getting pretty tight on time here, but so our latest project actually was the Quincy Smelting Works, located between Hancock and Ripley. So the Quincy Smelting Works was built by the Quincy Mining Company on the Portage Canal in 1898. The Quincy constructed the smelter to refine and ship its own copper, and also work with neighboring mining companies. Started out just as a couple of sandstone blast furnaces and support structures, and then they added as time went on. And then as the industry declined following World War II, it was no longer viable to operate. And so the Quincy closed the smelter in 1971. It was deemed a National Historic Landmark in 1978, and efforts to preserve the complex have been ongoing ever since. So kind of on a similar note to the Red Ridge Steel Dam, we worked with the, next slide, please. QAnon National Historical Park. Oh, I forgot about this. Sorry, whoops. So which company ran the smeltery?
We got another quiz question. Which mining company ran the smeltery? Quincy Mining Company, Copper Range, Atlantic and Baltic, or Calumet and Hecla? All right, I think they're going to get this one right. Oh, I don't know. I don't know. It's
You never,
A or
you never
D.
know. You never know.
It might be a trick question.
It's close, yeah.
Which mining company ran which smeltery are we talking about? I know the one you were, but what is it called?
The Quincy smelter.
So I think the answer is A.
That one. That's real stumper, you know.
We realized it right before we started the presentation.
All right, so A is the answer. If we were listening, then good. Yay.
But yeah, so resuming where I was, so on a similar note with the Red Ridge Steel Dam, we started to collaborate with the QAnon National Historical Park, with archaeological, industrial archaeological heritage in mind, and starting to preserve this site through 3D scanning. And so we were asked to do the dockside warehouse, which was essentially divvied up into two teams. One team was to scan the exterior and interior of the building, and the other team was to produce a traditional survey, which would give us coordinates in order to like properly georeference, not only this project with the dockside warehouse, but also future projects within the smeltery, going forward. And from there, we essentially just moved on to kind of just moving into deliverables that we gave to KNHP, which entailed pretty significant package with elevations, pretty much anything engineering that you can think of. And hopefully it's something that they can really make good use of and, add to their archives. And we look forward to kind of continuing the relationship with them going forward.
It was a beautiful day. You
And
had
I
to
will
do
pass it off
too.
the case.
You can move it to the next one. That's just another picture of the dockside warehouse. So once we were done with our day out at the smeltery, we went back to the lab and we started to do the registration and all the other things that we needed to put together so that we were able to give a deliverable out and to actually put something together that they want. So what we see here is a top-down view of the smelter itself. You can see the bottommost building, the one on the south side, is the dockside warehouse. So what's nice about having the ability to have two teams, we were able to split it up into 2 point clouds essentially. So we were able to put together 1 point cloud that entailed the entire building, and they were able to have the inside of that building, the outside of the building, and then we were able to take a second team around and get a more broad picture of the rest of the site. So the dark blue point cloud that we see here is our team that went around and tried to get a very broad overview of the entire site. And the very, very dense light blue cloud is the team that did the warehouse. So this is a scan. This is all of our scan points from that day. You can see that bottom building is, if you can really look at it, that's actually the rafters from inside of the building that you're seeing. We don't have a scanner we don't have a position that we could sit up above and scan down on top of the roof. So what you're seeing is the inside of the building, because that's all the scanner is able to grab. You can see that it kind of matches up fairly well with the buildings that we have in there. You can see that there's a couple dots kind of out in the field that kind of match up with the trees, and the fence lines fit. And if you look at the top left corner, you can see some points that are in there that are the power lines that we were able to grab. So we're able to do a lot of things. So what we're seeing right here is an elevation map of all the scans that we did. You can see that the roads are at a decent pitch, so it's the contours are very nice and look like a rainbow. But if you look at the ground itself, you can see that there's low points, there's high points. It kind of flows with the land. And you can even start to see when you go up to the north, to the top right part of the picture, you can see that there's a berm. You see that it's slightly going down, but it also has a very steep sides on on the bottom and top.
Mhm.
So here's just another view of the entire point cloud. This is looking at it from just a view that we're able to see a lot of what we've done. You can see the smokestack. You can see a lot of the outlines of the buildings. You can see where we missed spots where there should be building, but you can't really, there is no points there. So you have to kind of interpolate that there is something there. This just means that we're not done with this site, and we're going to have to come back out so that we're able to fill in these gaps. But that's for another day. what we can also do is we can classify the point clouds. So if all we're looking for on this site is the buildings, we're able to take the software and we're able to spit out anything that is remotely building shaped. You can see that the fences are blue, the buildings are blue, the smokestack's blue. You see a bunch of green in there. That's all the vegetation. It's smart enough to figure out if something is tree shaped, it's probably a tree. If it quacks like a duck, it's probably a duck. You look at the ground, it's something that's very flat. It slopes. It's not very abrupt. It makes sense that it's ground. So it's able to go through there and tell what's what. So eventually what we'll be able to do once we finish this whole property, we'll be able to draw building corners. We'll be able to tell them where the outline of the fence that they don't want anybody out, the berm that's kind of closest and in between the trees on this picture, that's the old railroad grade. If we wanted to know where the railroad used to come out and go towards Dollar Bay and whatnot, we would be able to figure that out. Or if we want to figure out where the power lines are, they're right there, even though those were power lines and way out of code.
Something to add too is the scans that we did from this side. It also picked up buildings from across the portage. It has that much range. So.
Yeah. So what I cut out of here is we have like D Stadium is scanned on one side. We have the boat for the out to Isle Royale, the Coast Guard and all that. Well, we have that scanned, but that's not something we were trying to scan. It just happened. But yeah, and then just another view, just kind of showing once again, there's just so much information that you're able to take and you're able to mess around with. But there's also a lot of holes that we're just not able to get as of yet because we only took one day out there to get a broad idea of what we need to do. So eventually we'll take out all the buildings and we'll be able to have a whole grade map of this entire property. What we see here right now is a elevation map at 1 foot intervals. So we can see that there's parts of this property that we have low spots, we have high spots. We can see that what we think is a fairly flat spot is a very sloped spot, but it just doesn't look like it. And it's just another step of trying to preserve what we have up here in the Copper Country.
It's awesome.
Yeah, and this will be more of what we output. This is the floor plan for the dockside warehouse. You can see we have a nice picture of just a side view of the whole thing. You can see if you're looking at the second floor, the timbers aren't straight up. The support joists, they're not straight up, and we're able to show that it's like that, and they're all tilted. And but yeah, and I think that's about all we have now for the smeltery. So
yeah, if I may, just again in closing here, Dean Callahan, we've got our organization, of course, the students, our Douglas Houghton student chapter of the National Society of Professional Surveyors, and certainly we are affiliated with the Michigan Society. We are a registered organization here at Michigan Tech, and our students take on projects like we've been talking about over the last while here, over and above coursework. So they're able to take that which we pass on in the class and apply it to actual use in the field, and is what we do as surveyors, as geospatial engineers. I keep pounding the drum. We are experts at measuring, and this is what we do. And we're fortunate enough to have the equipment and the environment to be able to use these things in such a way. One more slide there, if you could, Jake, please. And that's us. We will be attending the Michigan Society of Professional Surveyors Annual Meeting coming up the week of the 21st of February down in outside of Traverse City. Some of our members have already attended the Wisconsin Society meeting, which was about a week ago. Just to show you that every one of them are and we all are active in the profession and promote the profession, as well as the degree and the studies here at Michigan Tech. So with that, we just want to thank you for the opportunity to be able to speak with everybody tonight, and hope that it's been interesting. And it is a small part of what we do, but thank you just the same, and hope to see
Wonderful.
you very soon.
So I just want to make sure I thank all of you. This was you know, I know that it's a busy week in the semester, so thank you, Brayden, Wes, Case, and Jacob. Thank you, Joe, for, you know, all that you do for students, and thank you for doing these projects that really benefit the community. It's really been a pleasure learning a little bit more than I knew, which was very little, about geospatial engineering. And so what we will do now is we have quite a few questions. Because we're so close to 7 o'clock, I'm just going to thank the audience for joining us, and you're probably going to be peeling off as you need to go have dinner and so forth. Really appreciate you know, all of the people that I see every evening again and again. And so we will cut off the recording at 7 p.m., but we're going to stay on for questions because we've got quite a few open questions. So thanks again for joining us. This has been Michigan Tech's Husky Bites and the Department of Geospatial Engineering and the Douglas Houghton student chapter of the National Society of Professional Surveyors. Did I get it right?
Yeah, it's
You
about
got it. It's a mouthful.
All right. So pick a question, start answering it, folks. Everybody, all hands on deck. So read the question out loud, click on answer live, read the question out loud, and then answer it.
All right.
Here, grab one.
See, Steve had mentioned home department. Geo was in School of Forestry, and then they kicked us surveyors out. So we ended up at the School of Technology. So he changed his major into College of Engineering. Yeah, that's how it went, Dave. We're not alone. Beats the old Stadia surveying. Yeah, we still know how to do that though, Steve. Wish it worked underwater. Here's one. Can the scanning and processing be done quickly enough to be applied to an autonomous vehicle? Or if it already is being used that way, can you explain how it's being applied? Fire away, boys.
Yeah, I actually have a little idea of how that is. Currently, this is the idea of how autonomous vehicles work. What it's doing is, like Jacob was saying earlier, it's just spitting out light and it's trying to get distances from things. So where that ends up is you're trying to get distances, and you spit enough points out. Oh, that's the shape of a person. All right. It'll tell you, it'll know that it's a person, and it'll do whatever the autonomous vehicle would do if it knows that it's a person. If you know you're about to hit it, or somebody's trying to come across the crosswalk or whatever, if it's trying to figure out the lines on the road, stop signs, things like that, it's got to use the technology that we're using for scanning in a fast enough motion that it also knows shapes and things of the sort like that.
LiDAR was actually originally developed for autonomous vehicles, and surveyors kind of stole it. And then used it a little bit more accurately. But that's where we come in.
Yeah, we have that article.
Yeah, exactly. Did we ever shoot Polaris at Eastern Elongation? Well, that goes back a few years. I can say yes. You know, what we're looking for, Steve, if you're still on board here, we've got a couple of wild T2s and wild T1s still left over from back in the day. And as soon as I can get a right angle attachment for the scope will be out shooting Polaris, because a lot of these folks don't realize that there was stuff that had to be done before GPS.
So you did that in order to have a bearing? I mean.
Yes,
for-
exactly. That was actually either observe Polaris or the sun. And had to have a very accurate clock, timekeeper. But that was the way that you determine true bearing or true azimuth, rather. So
Very
yeah,
cool.
yeah.
Here's a question two questions from Stacy. What is the software you use to stitch the point cloud together into 3D model? And did Joe Foster go to Montessori's High School?
I can answer
You
the
get the
first
first
one.
one. You get the first one.
Yeah, I get the first one. So the software that we use to stitch the clouds together to register them is Faro Scene. So FARO, that's the company that makes the scanner. SCENE. That's the software that comes with the scanner that allows us to register the scans together. But then the software that we use to convert the point cloud to the 3D model is called Reality Capture, and it's made by a company called Capturing Reality.
Yeah.
And that software is also used for photogrammetry, and that's what we did with the photogrammetric model. So
And
on to
we there's another software that we also use is Trimble Business Center.
yes.
And that's the one that connects well with our SX10 and our deals with that, our 12s, our GPS, all our survey grade equipment. It all works through there. So so we're easily able to do our surveying stuff on top of the scanning.
All right, Joe.
Yes, yes, Stacy, I did go to Shores. I don't know, lead into how old I am, but I graduated from Shores in '82. So there you go.
Jeffrey asks, how long did these scans take? So for the scan of the Phi Kappa Tau snow sculpture, we were out there for probably maybe a couple hours. What'd you say?
Yeah, hour and a half.
Hour and a half, couple
2
hours. So it's really a function of how long you want to set up per scan, and that is a function of how many points and the quality of that scan, and then how many setups you want to do to capture that area. So yeah, about an hour and a half for the Phi Kappa Tau scan. For the dockside warehouse, that was a couple days of both interior scanning, and then some of the guys went back out on another day to do more exterior scanning. And I think each of those days are probably a few hours long.
2 hours long each, maybe.
Yep, about that. Becky says, is your light source a laser? Effectively, yes, it is a laser. So a laser is just a very concentrated beam of light. And that's exactly what the scanners use. And then they record that time of flight. And that's how we determine the distance and do that scanning process.
So have you guys, I mean, are you planning on scanning the winning statue again?
Oh, yes. Yep. We'll do that
Awesome.
again this year.
I think it's so cool. And then do you end up printing it for the
Well,
winner,
We
right?
print some of them.
We print some of them.
Where's it at?
We hypothetically could print it if we maybe brought it to the basement of the library or something. But for example, we printed the Husky statue ladder that we did.
Nice.
Where's the, do we have the elephant?
It's up on the radio.
This was one
Nice.
of last year's sculptures as well, so. He's missing his trunk. I don't know if you can
And a good chunk of his ear.
there you go. He's missing his trunk. The print didn't come out on that. But that was a
Oh,
little,
well.
If I could,
If I could speak to,
Uh-oh, Joe, you went silent. You somehow muted yourself. Start again. Joe, we can't hear you. Somebody tell him.
beg your pardon. Sorry about that. We want to address Walt's question here. If we could speak to job placement for the profession. He goes on to say he wanted to be a forester and took a look at the salaries and became a metallurgist. Well, I tell you what, in geospatial engineering, surveying engineering, our program here is 100% placement. And I'd say 110, 120%. We've talked about this before in other venues, but every one of our students is either fully employed or is employed shortly after they walk across the stage and get their diploma. And that's actually wide ranging. Nationwide, there's a tremendous need for surveyors, geospatial engineers. I've thrown this around before, but the average age of the licensed practicing surveyor in the state of Michigan, last I heard, was 60 years old.
It's jumped.
It's jumped. So either we're dying off or actually retiring or something, because I'm yeah, we never retire. It just shows the absolute need for entering this profession. And yes, the placement is very good.
And the salaries are good too.
Yes, ma'am. Actually, companies are competing for students. We get a couple of emails, phone calls a week, especially now getting closer to these annual meetings of the professional societies, and then also looking forward to career fair coming up. There's a great interest, and folks are very interested in what we have to offer.
Here's a question from J Lab Lander. He says, what's the accuracy of the LiDAR? So it depends on so there's a setting on the scanner that you can check. And the setting is divided into two different parts. It's resolution and quality. So resolution is the number of points per second that the scanner is spitting out. And the quality is the number of times the scanner is going to rescan the same position and then average those 2 points together. So if you have a higher quality, let's say you do 2 times quality, it's going to take twice as long, but you're reducing the amount of error in that observation. Because every observation that a surveyor makes, every point that a scanner makes, it has some amount of error. And that's due to environmental factors. It's due to maybe the scanner isn't perfectly level, straight up and down. So the general accuracy, it depends on how far away an object is, but generally we can get about millimeter accuracy. And when we actually register the scans, that is, put the scans together, the software will spit out a report and it'll tell us, hey, this is about the mean error in your setups. And usually they come out to about 1 or 2 hundredths of a foot. So we're talking maybe 4 or 5 millimeters in that regard.
Okay, so here's a really funny comment from Steve again. In summer survey class in 1985 in the South Range, they surveyed the South Range Cemetery at 3 to 5 a.m. I want to add like on Halloween night, but it doesn't say that there. That sounds like a very spooky project. Did your we have to connect about this. Did your instructor make you do this?
Oh, you
Made the same chunk of ground out at the South Range. I forget the 40 and the section and the town and range, but that's where we did all our ground surveys. And I see Richard has given us all kinds of heck. He says that we have it easy. When he graduated civil in the 60s, had to spend an entire summer surveying. Oh, you betcha, we did too. 8 hours a day for 12 weeks, 2-hour lecture and 6-hour field work, pulling 100-foot steel tape using a wild T2. So yeah, you betcha. But yes, that same cemetery, that's where we took our, there was an old railroad grade that run through it or near it. And that was the site that we would observe Polaris on to determine true bearing on it. So yeah, it was 2-3 in the morning.
Well, and so Nicole, who I know is in Alaska, she says, as a side note, the United States Air Force and government is looking for surveying people as well. It takes longer to onboard, up to a year, but tech alumni are all over where she is. Or I think. I'm pretty sure Nicole's in Alaska. She was in Hawaii, moved to Alaska. Explain that to me. I can't. All right. We still got a lot of questions, but it doesn't look like some of them are just comments. So there's a few from Steve. Steve's friend installed the plaque in 1987. And then
Yep.
he's surprised the dam is still allowed to stand, given Michigan, Michigan with dams in the Midland area. And I can't explain that. And maybe someday they'll remove it, but it's historic, Steve. They're not going to remove it. There's only 3 of them.
Yeah, exactly.
So what does anybody each want to pick one last question or else a comment about the profession? And so I don't know if you are all graduating seniors or close to graduation, but a chance for one last question or comment. And I'm going to call on people. We're going to end up with Joe, and I'm going to call on Brayden first.
Oh.
One last, go ahead.
Let me bounce because I don't have the questions up.
All right, Wes. Wes.
One second, I'm sorting through the. All right, I'll answer Joseph Lett's question. So when scanning the statues, how long do you sit on each setup? So like Jacob had mentioned earlier, it really depends on what settings you choose for an individual scan. I'd say typically when we're doing projects like this, it's usually anywhere between like 5 and 10 minutes, usually around like the 7-minute mark per setup. Obviously how many setups you have kind of varies depending on how big your object is, how much detail there is, if there's a lot of things to capture in between objects on a certain site, also all that good stuff. So yeah, it really just depends on what you're trying to capture. But I'd say on average, at least with terrestrial LiDAR with the Faro unit that we've been using, it's about 7 minutes, 5 to 10 minutes, kind of in that range.
Well, and a follow-up question. So for every hour that you're out there in the field kind of collecting data, give me an estimate of how long the post-processing takes. Is it about the same?
Oh boy.
Depends on the site.
Yeah, it depends on the site. Depends on, how well we did our, like Jacob was talking earlier with, keeping objects that you don't want in there out of the way. Or, foliage, things like that. People, trying to make sure that scans line up well with coincident geometry. So like targets and whatnot, or building corners, things you can pick out kind of between 2 scans and just kind of say this is where they meet. But again, yeah, that can really vary.
So you've learned enough. You've learned to, if you're going to do a job, to specify with like all the things that are going to take you the extra time so that you can
but I'd say maybe
approach.
time and a half to
Okay.
2 hours. So like 1 hour in the field could be 2 hours in the office post-processing.
That's not too bad.
It really just depends on what you're doing too.
Because you can choose snowy days to do the processing, right?
Yeah, when it's not -10 like it was last winter carnival.
We had some cold weather last week too. So Case, how about your next? So you can make a comment or, something you love about the field or love about Michigan Tech, or choose a question to answer.
Well, I'll do a little of both, but it is definitely a fantastic program that we have here. It's definitely a great time. Just being able to have all this equipment available to us. Very thankful for our people like Geospatial or Siler Geospatial and just everybody else who is very good to our program here. But I'm gonna answer Michael's question. What's the greatest advantage or benefit of geospatial over high def photography? So it depends on what you're trying to scan, because with the Husky statue that we have, it's one color, it's bronze, so it's it's very hard to tell what the contours of the fur on the Husky's back is. It's hard to figure out things like that. So when you use LiDAR, it's able to pick up everything in between there. While if you're trying to compare photos, it's very hard to say this black dot is this black dot on this picture. So it depends on the things. Like if you're trying to do a parking lot, it's easy enough because it's not very changing. If you're trying to do a forest, or you're trying to do a anything like that, it's going to be a lot better to use LiDAR. But if you're trying to do like a building facade, you're trying to do a that's good example. If you're trying to do a building facade, it's very easy to tell this point goes to this point on this picture, and that one goes here, this one goes there, this one's this far away from here. And something that's got very easy geometry is what makes it high definition photography better in some cases and LiDAR better in others.
Well, something I want to add to that, I'm gonna dovetail into that. Using Mr. Foster's terminology, is that, you know, photographs are great, right? Like we can take a picture of something, like it's a really, really amazing invention. And we're kind of having another amazing invention coming around with geospatial imagery, right? Because for like the past about 200 years, we've been able to take photographs, but now we're able to take 3D photographs in a sense. We can go out and it looks a lot different than taking a photograph, right? When we take a photograph, we stand in one spot and we take the picture. And that's cool. We have a 2D picture of, let's say in the example of the Winter Carnival statues, you know, we have a nice picture of the statue, but there's something so much more, there's no better word than just cool about being able to click and drag on the screen and seeing it spin around in 3D, and you could zoom in, look at any little part you want, look at the whole thing. It's just, there's something really fascinating about being able to turn a real world object into a 3D computerized version, because it'll just last. I mean, the internet has already gotten so big, it's pretty hard to lose data nowadays, you know, especially like with the cloud, that having such a big presence. So, I mean, these real life objects can be virtualized for potentially virtually forever.
All right. All right. Thank you, Jacob. And so Brayden, got a question or a comment?
Yeah, I'll go on to Steve's. Does the survey class still do triangulation across the portage? No, we do not, but that sounds like fun. For one class, we do GPS on benchmarks, where we went out to McLean's and we did 2 4-hour sessions with a GPS, so 8 in total on a couple of benchmarks. And that was to establish XYZ coordinates right off the basically breakers. And that helps build like the datums and state plane coordinate system. And yeah, but helps the government and it helps us learn, but no triangulation across the portage anymore.
All right. And so again, I want to thank everybody for joining us, and I want to leave Joe to have just a final last remark. And again, thank you, all of you. This is the biggest team I think we've ever had on live like this. Joe, close us out.
Yes, ma'am. First, I want to thank you for allowing us to come on board here again, and it's really enjoyable. As you can see, that nothing but top shelf around here. Great group of students, wonderful community. I'm an old tech grad, so I'm going to be biased, but I got to tell you what, Michigan Tech's got it going on. We haven't triangulated across the portage, but I did have a bunch of students do a topographic survey of Mount Ripley the one semester, so in the snow. So we try to spread it around, but thank you so much, everybody that tuned in, everybody that viewed, and we appreciate all the support and welcome an opportunity to do this again. So Thank you again.
All right. Good night, everybody.